have vaccinations in about 3 weeks. And so that'll be first vaccination, and then 21 days or 3 weeks after that will be the second vaccination. So that puts us pretty much, puts me at the end of February. And sorry, but I have health conditions, and I'm in a more vulnerable spot than the average bear, so or the average wildcat. So I will be with you every day. I'll be grading. I'll be teaching you. It'll be just like what we've been doing since the middle of November, but Mr. Wolfman will be with you in the classroom, or someone will be with you in the classroom until I can safely return to campus. So the calendar is pretty straightforward. No homework today because of the quiz. So I'm going to give you a little bit more information about periodic trends. We're going to get through ionic size, and then review the periodic table that you'll have for your use on the quiz, and then take the quiz. And I do need you to stay last period. People left the meeting before they finished their quiz, so they're going to have to take the makeup quiz. And I'll have to have a discussion with them. So you can leave when you're all done, but don't leave until you've submitted your quiz. You can't leave Science 4 until the bell rings, but you can leave if you're on distance today. All right, so let's get going. You got this note sheet on Tuesday, and we just talked about what ions were and how metals lose and nonmetals gain electrons. We're going to review that and then talk about ionic size. And then tomorrow we'll talk about ionization energy and electronegativity. Wrap up our week on chapter 6. Now next week there will be a test on chapter 6. I haven't decided if it's going to be Thursday or Friday yet, but that's my plan. I am going to go in this weekend too. I have to share this with other classes, but my plan is to go in this weekend and film some reactions for you so we can talk about that together. All right, I want to find my secondary. It's here somewhere. There it is. All right, I'm going to start by reviewing this slide because it's something you're going to have to really get in your brain to be successful when we get into making compounds, which of course is what the fun's all about. So let me change my color here. All right, we're stuck with red. Sorry. Here we go. So you know that the periodic table can be divided into S, P, D, F blocks. You know that the two columns on the left are the S block, and the 6 columns on the far right are the P block elements. And hopefully you know that S and P electrons are called valence electrons. And hopefully you remember that everybody wants to get an octet. You want to get 8 valence electrons, and that will fill your S orbital 1, 2, and then it'll fill your 3 P orbitals 1, 2, 3, 4, 5, 6. Hopefully in the Ed puzzle you watched yesterday, I know you talked about the transition metals a little bit in some of the words. Oh, I know, it was nitrogen. Nitrogen compared to oxygen because of how they have half filled versus symmetry in their P orbitals. Sorry about that. To remember which elements. What else I want to tell you? So again, most elements are metals. Everything on the left, metals are losers. They lose valence electrons. This column is a little tiny bit confused. So this is the group 13 borons family. Boron, and then right below boron is aluminum. So there's a little stair step, and we're going to go over that the marks between metals and nonmetals and metalloids, borons and metalloid. All the other elements in boron's family are metals. And what do they do with electrons? They lose them. How come? Well, group 1 elements have 1 electron in their s orbital. Group 2 elements have 2 electrons in their s orbital at the highest energy level. It's a mouthful. Boron is in the P1 column, so its configuration ends with P1, but it also has S2. It has 2 plus 1 or 3 valence electrons. Everybody in this family has 3 valence electrons, and so all of them, let me just fill in a couple more bits of information. Carbon is 4 valence electrons, then nitrogen, oxygen, 5, 6, fluorine, and neon. So it goes 3, 4, 5, 6, 7, 8. And we're going to ignore carbon because it does similar things with electrons. But just remember that 1, 2, 3, 4 is in the middle, 5, 6, 7, smack dab in the middle on your way to 8. So what elements that have 1, 2, or 3 valence electrons do is they lose them. That gets rid of an entire layer of electrons. Or onion shrinks down to a smaller size, if you will, and they get noble gas configuration. So remember 18 or 8A, those are the noble gases. All elements are trying to get the configuration of a noble gas. On the other hand, if you're nitrogen, you have 2 and 3, you have 5. If you're oxygen, you have 2 in the S, 4 in the P's, for the fourth column of the P's. You have 6. If you're fluorine, you have 7. If you're noble gas, you have 8. So if you have 5, all you got to do is get 1, 2, 3 more to get 8. If you have 6, 1, 2 more, and you've got 8. 7, you just need 1 stinking more electron to get 8. All of these non-metals gain electrons and get more negative charge. And they're doing that to get the noble gas configuration. You probably, we already did this, I think, on Tuesday as well, but the superscripts tell you that there is a charge, so that tells you that this is an ion of fluorine, which we call the fluoride ion. The fluorine atom has 9 protons, it's element 9, atomic number 9, and 9 electrons. But again, because fluorine ends with 1, S2, 2, S2, 2, there we go, P5, 5, and 2, it just needs 1 more electron to get an octet. So it grabs that electron and gets a -1 charge. The 1 can be written, I'm totally fine with you guys writing -1, but again, just like in math, you don't write 1x, you just write x, and it's understood. And same thing here, but I don't care if you want to write 1, you can. It's not that much pencil lead. So losing an electron means the electrons go away. It means you're still left with positives. Gaining electrons obviously makes you more negative. I hope obviously electrons are negative. So minusing a minus makes you positive. Right? Like math. So magnesium is in, magnesium's in the alkaline earth metals, column 2, and magnesium ends with, it's on 1, 2, third line, right? S block, it ends with 3s2. Well, what else does it have? It also has all the other things, right? 3s2, and again, we don't write 0 because that's a waste of time. But 1s2, 2s2, 2p6. Okay? If, like I said, all the elements, every single one, top to bottom, they all behave the same. If it loses these 2s electrons, what does it gain by doing that? It gains S2P6. It gains noble gas configuration. Okay, so this +2 means magnesium lost 2, +1 means this particular copper ion lost 1. You add electrons, you're going to get more negative. Fluorine gains 1. Oxygen always gains 2. And actually the proper way to write this, I've mentioned this in other classes, is you write the number first and then the charge sign. I don't care. Okay, it doesn't matter to me as long as you can figure out what the charge is going to be. So again, they're trying to get, sorry, I kind of jumped the guns there. Every atom wants to get the stable configuration of a noble gas. S2P6, and they're either going to lose their electrons if they're metals, or they're going to pick up somebody else's electrons if they're non-metals. That will make every atom, when it forms an ion, not all of them form ions, but they can, okay? When those elements form ions, they become iso, and remember that means same, like isotope, same element, different number of neutrons in the nucleus. And of course, electronic has to do with electrons. So atoms will gain or lose electrons to get isoelectronic with a noble gas. Okay. It's a little tricky figuring out which noble gas. So let's say it's the closest noble gas, except when you're a metal on the left-hand side of the periodic table, the noble gases are way over here. So that's a really, you just have to remember, if it's on line 3, okay, it's going to go to the noble gas at the end of line 2, which is neon. If you're on line 4, you're going to go to argon. Unless you're on, if you're a metal, unless you're a non-metal, and then you're going to go to the guy next door, like fluorine goes to neon, oxygen goes to neon. However, so does magnesium. Magnesium gets isoelectronic with neon. I'm going to skip this. We've already looked at this once, but I want to make sure we have time to review it. Whoop, sorry. So the size of atoms shouldn't surprise you. Remember, lithium, sodium, potassium, they're in the alkali metal column, the first column. They have 1 electron to lose. If you lose something, guess what? They get smaller. Okay, so the ions are smaller than the neutral atom. Group 7A, the halogen, 17, fluorine, chlorine, bromine, iodine, acetine. All of them have 7 valence electrons. All of them grab an electron, quite possibly from an alkali metal, but that electron comes in and it makes the ion larger. That works for cations. Anions get smaller. Excuse me. So those absolutely backwards. I'm so sorry to confuse you. Cations are smaller. It's the common stuff. Anions get larger. Okay? And it should kind of make sense. If you lose a layer, you're going to be smaller. If you add an electron, it's going to make you bigger. All right, so ionic size is one of the periodic trends that repeats itself. And what we notice, again, and this is just to re-emphasize, I can't say this enough, metals lose, there's on the left, cations, positive ions. Non-metals gain, so they get more negative, those are anions. And everybody wants to be like a noble gas. Everybody wants to finish up with S2P6 for their outer layer. General trends, when you're looking on the periodic table, going down a group, oops, that was not in the same group. Oh my gosh. There we go. Going down a group, lithium, tiny, sodium, bigger, 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 bigger. Top to bottom, they get bigger. They've got more layers of electrons. Notice, however, if you go across a family, or across, excuse me, a period, oh my gosh, it must be the end of the day. Sodium, magnesium, aluminum, bigger, smaller, smallest. Okay? So left to right, they're getting smaller. Top to bottom, they're getting larger. That also happens, so these are our cations. And then our anions also follow the same pattern. Bigger, medium, small. Of course, there has to be two of the exceptions. They have to put those in there. But the general thing, and they're not that much different. The general pattern is, again, left to right, small. So this is from our book. Cations decrease. Those are metals. Anions also decrease. Now, yes, it's bigger than the starting atom, but ion to ion to ion to ion is a little bit smaller most of the time, except for the big ones. And then top to bottom, smallest at the top, biggest at the bottom. And again, this is just like atomic size. Okay? So it follows the same pattern, it's the same reasoning, how many layers of electrons you have, and also what size is your nucleus. And the only caveat that I want you to remember, and because this is important later a little bit, cations are smaller than the atoms they start from. Anions are bigger than their starting atoms, neutral atoms. And we'll use this for review on Thursday. So that's a lot of information. Does anybody have any questions? Questions? Again, ions are charged particles, gained or lost electrons. It doesn't, depends on what type of element you are. All right, seeing no, question, or is that just a previous, okay. We're gonna go ahead and review them. And there's a periodic table. This is the one you're going to use. It's from Wikimedia. No distinguishing characteristics, no color. It's pretty boring. Remember when we started this out, we talked about the broad categories of elements, metals, and non-metals. And my dumb way to help you remember that is metals are on the left, losers on the left, and non-metals are on the right. This little staircase marks the boundary between metals and non-metals. And about 80% of the elements are metals. Elements that touch this staircase are a little on the confused side. Okay, they can't decide if they're a non-metal or a metal. We call them metalloids. Hopefully that isn't anything new for any of you. Okay. So your periodic table is not going to have that. The ones in the classroom do, so you guys have a little bit of a commitment there. Remember, aluminum does touch it, but aluminum is a metal. Everybody knows that. Group 1A or Group 1, remember they go 1 through 18 for family columns, and then we have 1, 2, 3, 4, 5, 6, 7 periods or rows. Remember, hydrogen's a non-metal. It's acts like a metal because it loses electrons, but it's one electron. It's little. But it behaves like this first group. These are the alkali metals. They all have one valence electron. Alkaline earth metals are group 2. So it's a 2-part name. Well, it's 3 parts, 3 words. Alkaline earth, that's beryllium, magnesium, calcium, strontium, barium, radium. And those are the S block valence. And then this middle region, you guys know, those are the transition metals. These are the things you think of as real metals. And of these are also metals down here, even though they're not part of the transition metals. And we've got boron's family, carbon's family, nitrogen's family, oxygen's family. Super important group, 17, the halogens. Fluorine, chlorine, bromine, and iodine in particular. And then group 18, those are your noble gases. Everybody wants to get S2P6 like a noble gas. And then finally, the last two are lanthanum and actinium. They're the F block elements. And our book also calls them inner transition metals. So we have time to do a little reviewing. So I'm going to leave this periodic table up. I'm going to get my PowerPoint gone. I'm going to turn off the recording so you don't feel uncomfortable doing the answers or as uncomfortable.